All right, I think we're ready. All right. What do we have? Last time we added our dual Z axis over here on our printer. We added this second axis over here. I noticed later on that I actually plugged the Z motor into the extruder spot instead of the Z spot. So I had to flip the wires in here for fixing that problem, because that wasn't going to work very well. And I haven't actually checked to see if I put the extruder in the right spot. I should probably check that. This particular board that we changed out does have 2 spots for extruders, I think. Let me check the little schematic here. X, Y. No, it has 2 Z's. So I actually think that I do need to switch out the extruder motor. I'll just show you because we need to do that. Let's turn it off, and then let's go down in here, and I'll show you what I did, because I think I still have done that wrong now that I look at the wiring diagram. Technically, we should probably also unplug this. That's coming from the little clipper computer. Yep. So this is the Z cable that we were using to power our 2 Z motors, and it's currently in the right spot, X, Y, Z. But this is ZB, I guess, or whatever. And this last one is the extruder. Oh yeah, remember it being very tight and just barely reaching there. There we go. All right, now we should have extruder and Z motors. We can plug that back in. I think we will do a little bit of printing today. Not the main focus for today, but I do have the aero filament, so the lightweight foaming filament, and I thought maybe we'd print, assuming we can get it up and running. I thought we'd print a comparison model of the lightweight filament versus just the plain filament. I have this, what is it? I have this stuff, the champagne color. It says metal, but it's not actually it's metal colored. So we'll print that as our regular PLA, and then we'll print we'll try all of this stuff that I'm talking about. We'll try printing the lightweight PLA. All right, let's get that back going. I do have to restart over here because, oh, and I added the light. So let me tell you about this light. You'll see it come on here in a second once it powers back up. But let me show you this light. There it went. There you can kind of see what it's doing. Let's see over here. This is the one I added to it. This one actually goes to a enclosure, so it's supposed to be in one of these enclosures here, which we do have over here. But if I put the printer in the enclosure here, you won't see it at all because it's kind of enclosed. Yeah, I guess you could kind of see it, but it takes up more space and it's just harder to deal with in this setting. So normally you use these enclosures for a couple of reasons. One, you're enclosing the printer so that you can have kind of a heated chamber effect where the printer bed is actually heating the entire enclosure. This is good if you're printing some filaments that like to warp. If they're cooling slower, so they're in a heated chamber, then they are less likely to warp. You also do it if you're printing something that's obnoxious to you in some way, like it smells bad, or maybe maybe it releases some sort of nanoparticles or micro, whatever. And you can enclose it in an enclosure. You can actually even vent them out. Some of them have vent kits that you can vent out to the outside or to some other place anyway. So we do have that, and this light actually goes with one of those. So it doesn't exactly work. So I'll show you. There it is. It normally would clip onto a rail inside the enclosure, but here I've just got it clipped on the upper gantry part. I didn't even really route the cable for it. There is a better light that I think I'll go ahead and put on here. Actually, I may not put it on here. Those might be some of the prizes for the contest, the catapult contest. This does work. It kind of forces the light to go somewhat down, but also out, so it's not aiming all on your print area down here, but it kind of adds some. The actual light that goes with these aims straight down. Let me see if I can show it to you. I also have that one. I just didn't. It's a little bit more difficult to install. Here it is. This one, currently unavailable, so you have to find another version of this thing. Not sure why it's currently unavailable. Maybe they have changed it up a little bit. So the downside to the one that I did put on here is that for one, it's not made for attaching to a printer. It just happens to attach. Number two, it powers by USB. So in our case, that's okay because I'm just powering it off the Raspberry Pi right here. So we can do that. I'm not sure why we didn't log in there. That's kind of strange when you have to restart. So let's go ahead and restart that because it should. Oh, maybe it was about to log in and I was too anxious. So in this case, it doesn't matter. But your printer normally doesn't have an empty USB slot on it. This one powers in a more convenient way. You can I don't know if you can see here. You can actually wire it directly into your board. So you would have to open up the motherboard area and wire these into a 12 or actually a 24 volt spot for the Creality. Always on. This one does not have an on-off switch, I don't think. So I think it's just on when the printer's on. The one that I have attached right now does have an on-off power switch, which is nice. I suppose, I don't think there's an on-off in here. It's kind of hard to see what's going on in there. But I don't think there is. I think it's just a light bar that's on when the printer's on. But this one does, it also mounts to the top of the printer, but it does face directly down. It kind of overhangs. Let's see if there's a picture of it. There it is. Kind of overhangs and aims straight down. So that's kind of nice. Oh, it's just saying that it's a LED light and it doesn't strobe. Okay. I might put this one on the printer. I might use it as one of the prizes though for the catapult. All right, or we did boot back up there. So let's go and let's print some models. Just a cube. Let me get Cura going so that we have a cube to print. Oh, I used the old version of Cura apparently. I didn't even look at it. This is the slightly outdated version, but it's going to be fine. Oh, but we may not have put our printer in this version. We may have to start the other one. It's loading up. We're just going to drop in a regular cube, print it with regular settings for this PLA, and then we'll use the exact same settings -1 for the Aero, the lightweight PLA. The one thing we have to change is the whole point of the lightweight PLA stuff is that when you print it, it foams up and expands. So it has a lot of air in it. So what you have to do to account for that is you have to reduce, like significantly reduce your flow rate to account for the expansion of the filament. So typically I think we're going to print at a lower temperature, not like low, but at the lower end of what this filament prints at. And we'll probably have the flow rate somewhere around 60%. Let me start the other Cura because that was 5.4 and I'm pretty sure we installed this printer on 5.10. They might share a database where all the printers are shared between them. I'm not sure. Let's just start the one that I am pretty sure we were using. In the meantime, let's load up first our champagne filament here. Be careful, not careful, but be aware. Some companies, when they vacuum seal in a resealable bag. And I don't know how many times I've punctured the middle of it and then realized that, oh, it was a Ziploc type resealable. I could have just opened it and saved the bag and reused it, but this one's not. So this one is just a plain vacuum seal bag. So there's what we're going to print our little cube in. So I have not changed the location of the filament. It's still sitting on top of the printer, which I don't like once we start trying to print at faster speeds, but we're just going to print regular speeds. So we have to heat up the nozzle. We haven't done that yet. Let's see. Extruder temperature. Let's go for PLA, which is going to go to 195. That's fine. That's just I was just doing that on our little high screen here, and I have never changed the default settings for what these preheat numbers are, and apparently it's 195 for the extruder and 40 for the bed. Alright, so while it's heating up, let's go back to Cura and let's put in a part and just a cube. We'll just print this. Now we do have to remember that and I'm not sure how this will affect the arrow, so we may have some odd things, but we have to remember that this particular printer, we put a 0.8 millimeter nozzle in there, so we have to, and it's remembering it here. It's off your screen. There we go. It's remembering that it's a 0.8 millimeter nozzle. This brand of filament is, let's see, it's one of those that just doesn't tell me on the spool. I don't like those. You'd think that they would want you to know what filament type, what brand you're using, but probably Elegoo, I don't know. It's not on any of the packaging that I see. So we'll go with generic PLA. Layer height, let's go with, since we have a 0.8, let's take advantage of the ability to do large layers, and let's do 0.6 millimeter layer height. Well, no, let's do 0.4, because I don't know how the arrow is going to go at these larger layers. Actually, let's do 0.3. That's closer to what I'm thinking might work. So it'll take a little longer to print because we're doing thin layers for this nozzle, but I don't know how much this foaming PLA is going to be able to foam. So I'm not going to experiment right now. We'll experiment later. Let's do 2 walls. Let's see, 3 top layers, 3 bottom layers. That's fine. Infill at 15% cubic. 240. That's a high temperature for PLA. We don't need our bed that high. Let's do the bed at 50. So with the foaming PLA, the stuff we'll print second, the hotter it goes, in fact I've got the little table right here, the hotter you print it, the more it expands. So if we print at 240 for the foaming PLA, it says our flow ratio is supposed to be 45%. So it's going to foam, a lot, 55% more than what it expects. Let's do in the 220 range. That's kind of in the middle for the arrow, the lightweight arrow, but it's upper end for regular PLA. So that's going to give us a flow rate of 76%, it says. We haven't tuned any of that, so I don't know. So it's going to foam somewhere in the 30% range. All right, let's go back to Cura. So let's go 220 for our printing temperature. I just want to keep as many things the same as we can. Let's actually check what the flow rate is currently. It's at 92%. That has to do with, we were doing a particular experiment. So let's go back to 100. And let's go with that. Okay, speed. All right. See what else we have to change. Print speed, that's kind of fast. Let's do 70. I think I was trying to do a flow calibration test. And so I had these kind of changed. Let's see, print cooling, yes. Oh, remember we had printed that, that's what it was. We printed that that Time-Plast filament, the soap filament, and it had some really weird settings. I probably should have just reset everything, but our fan speed for these is going to be 100%. So it's going to be off for the first, let's just only do the first 2 layers. So let's go to regular speed at layer 3. That'll give us the first 2 with it off. Skirt is good. We don't need support. All right, let's slice that. Let's preview it to see make sure it's going to look more or less what we think. We've got the flow scheme on there. So let's go to just line type. Okay. Not much infill. That looks reasonable. All right, we'll save that. I've got to figure out what our IP address is for our little clipper. It's the same it's always been. Let's save this on the desktop, and this will be standard PLA. Okay, let's go to our clipper screen. Everything looks relatively normal. Except that we have not ever gone in and added a startup G-code, so I need to home all on the printer. It is homing. It's much quieter than it used to be. Oh, you know what? I haven't moved the Z-axis, so hopefully that works. All right, so Z-axis is working. And the CR Touch worked. I did see, there's one issue here. I don't know if you see it or not, but the way we've just probed for the Z height is okay, but what it's doing is it's probing with the nozzle in the middle of the bed, not the CR Touch in the middle of the bed. CR Touch is over here, so we need to work on our offsets for the offset between the probe and where the nozzle actually is, because you really need those lined up. Well, you don't line up the probe and the nozzle. You need the offsets to account for the misalignment of the probe from the nozzle. There are some printers, not many, but there are some printers that use the nozzle itself as a probe, but this is using a separate probe. And so we need to account for that offset in our printer configuration file. It's been a while, maybe a week or two when we did this, but basically we just grabbed the SKR Mini E3 printer config from their website and plopped it into our clipper and didn't really change much. And that's one thing we need to change, is we need to add that offset. Anyway, I think we did a PID tune and that was about it. All right, so let's go ahead also over here. This one, and we said we were going to print at 220 and at 50. Let's go ahead and hard code those in here because they're not going to be in the startup G code because we don't have a startup G code. All right, let's load up our files. There was our soap file that we printed. I called this standard PLA, didn't I? There it is. And one thing, we have not actually loaded the filament, so let's do that. It is heated up enough, so let's get this in here. Okay, looks like it's, yeah. All right, so that's good enough anyway. So we won't have any like purge, anything. It's just going to start printing. So that'll be a fun time for us getting that set up. All right, so back over here on Clipper, I'm just going to print. I'm going to start the job, and I'll be over here because if I remember right, the Z offset was really far off from here. Maybe I saved it. I don't know. We'll see. All right. I must have saved it because it's actually really close to the bed now. So we got to raise it up. All right, so we got something working there. Looks okay. So 14 minutes later, that will be done, and we'll do the same thing but with our arrow, lightweight arrow, and then we'll measure, you know, is it actually lighter? We could encounter problems with the aero print. I don't know. All right, we'll let that go. Hopefully it sticks down and we'll be all right. It looks... Oh, you know what? It's still really close to the bed. Let me raise the Z up a little bit. I know you can't see because it's underneath here, but what I'm seeing is the first layer is really, really raggedy. You might have caught some of it right there, because the bed is so, or not the bed, well, the bed is so close to the nozzle that when it extrudes, it's really pushing it out sideways, and it's rumply and raggedy. So I raised up the Z offset a little bit. I think we probably should raise it one more notch here, and then see how it goes. That raggedy sound, that was the nozzle dragging across the rough first layer. All right, so what we're going to do while this thing's working is last time, so Friday we didn't actually meet, so I don't know what you did that Friday. Maybe you watched one of the older videos, but the last time we were here, we did this, or at least one of the things we did is this guy. So we made this guy using, this is the HiTem3D.ai, and we gave it a picture of Spawn, and it generated this model. So most of it's reasonable, you know, it's not great, but it's reasonable. But his head is ridiculous. Like, look at that. That's ridiculous. And then he's missing a finger, or maybe a pinky finger over here or something. So, well, among other things, these chains are kind of weird. You know, they doesn't know what's going on with the chains. He's got a really, really strangely formed leg there. But what we want to do today is, let's say that you generate one of these AI models because you maybe don't know how, or don't want to take the time to try and build one of these from scratch in some sort of modeling program. So you start here, and it's like, well, that's kind of okay, but I really don't like, you know, that's ridiculous. I gotta do something with the head. So you could try to just keep regenerating the model, you know, give it better input, or you could give the idea that I'm just going to model the head, and I'm going to maybe just draw in an extra finger somehow, and so you're going to edit it yourself. So that's the approach we took. I downloaded this guy. Did I download him? Yes, I'm pretty sure I downloaded him, and then I gave some other just headshot pictures. So I did this one first, and it's like, okay, that's better, but still not great. And then I did this one, and it's like, this one's, you know, I can go with that one. That looks a lot more like what Spawn is supposed to look like. Now the problem is, this is not attached to the body. So I've downloaded both of these. I've downloaded this, and I've downloaded the body. And we're going to go over to another piece of software called Meshmixer, which we've used a little bit. And we're going to attempt to attach those two things together and maybe fix his finger. So Meshmixer is over here. Right now, apparently, I've got the Lady of the Mist in there. So let's import, but let's replace the Lady of the Mist. Let's import the body. Where did it go to downloads, maybe? Probably these 01 and 02 STLs, I guess. Let's see. Now these are large models, meaning not that they're big, but they have lots of data in them, and we may have to rethink what we're doing here because kind of stuck. Or, oh well, that was his head. All right, so that's not the one I want to work with first. I do want that, but not right now. So let's replace that one, and let's use the other one. I guess it was this one. Our little cube is doing okay. It's not perfect, but it's okay. Now, This is Autodesk Meshmixer. So it is a Autodesk product, although they didn't develop it, they just acquired it, and they don't support it anymore with new releases or new updates or anything like that. What they've started doing is they've started rolling these same features into their Fusion product. I have not used those features in Fusion, so that's why we're over here in Meshmixer. All right, so here he is in his not oriented correctly, or we'll fix that. But all these little red dots are potential errors. So one of the first things we can do is go to this analysis button and go to the inspector. And some of this might be really slow, but we'll try to power through. So it has found all of these are holes, or they're overlapping triangles, or whatever. There's some issue that is identified in all of these little points. So I'm just going to try to let it fix all of them. So there were 179, and it's trying to fix them. Okay. All right. Seems like it's better. Let's get him oriented at least with the plane the right way. So notice in our little cube up here, it thinks this is the front view. So he's laying down and sideways. So let's go to edit over here. Well, let's do that. Done. Let's go to edit, and then let's transform. So we get a little gizmo here, so easy enough to rotate him. Right there. Although that doesn't make his feet look quite... Oh, he's standing on his tiptoes over here. This will let him go upwards a little bit. Can't really tell where the ground plane is there. Let's rotate him to where this is actually the front. Oh, it looks like we're still below the ground somewhere. We'll deal with that at some other point. That's not super important right now anyway. Let's rotate him, looks like about 90 degrees that way. See if that looks... Oh, he's kind of crooked. That's why his feet aren't matching. One of them's taller than the other one. We'll have to see if we can work on that. All right, this is better. All right, our main goal here, I think I clicked accept. Oh, I started to tell you about Meshmixer. So in the large model files. So I don't know if you can see it down here, but we're at 2 million triangles. So that's getting on the larger side for Meshmixer. It does have a habit of crashing with larger model files. So if you're working on something in the large number of triangle arena, then it is probably a really good idea to save often. So I'm going to save as, this is the Meshmixer format that it's going to save it in. That's fine for now. We can't print with that, but we can export from it. So let's not put it in downloads. Put it on the desktop, and we'll just call it spawn 1. All right. Now, let's work on removing this ridiculous head. All the cloak and cape stuff, all of that stuff, it's very random in the actual character, so we could change that. I kind of liked the other one, how it did it better than this one, but that's not what we're too worried about. But the head's ridiculous. So how we're going to do this is, there's a couple of ways, but most of them have to start with this select tool, because we want to isolate the head and then either just chop it off or manipulate it somehow. In our case, we're going to chop it off of there and plop down the other one, hopefully. So I think what we'll do is we'll go to the lasso tool, and we will kind of do something like this. All right, so now we've, I just unselected. All right, let's go back to the lasso tool. Oh, actually we're on the line tool, that's okay. That might give us a little more control. It's getting a little bit laggy. make those overlap. All right, there we go. Now we've got the head isolated, where any changes we make will only affect whatever is selected here. So I think what I'm going to do is I'm just going to chop the whole thing, including the cloak stuff, off of there. So edit, I'm going to do a plane cut right here. And we will take this plane and we will cut, let's see, I think it's currently cutting off below the plane. So let's flip the plane over. This is where it's getting kind of laggy. It's not your screen that's lagging, it's Meshmixer. Kind of line it up. I'm trying to line it up so that I'm left with a neck stub of sorts. And if I didn't do that select beforehand, then I would also be chopping off his shoulders. So something like that. We'll get a preview and see. All right, so this little fill type is, since I'm going to chop off part of it, how do you want me to deal with the open neck? And I just want to fill it flat. So you could not fill it at all. You could just do a minimal, remeshed, or fixed. I'm just going to do remeshed. That'll be fine. Or maybe it'll be fine. I don't know. Let's accept and see what happens. Oh, so, all right, so I don't like that. So it chopped into, it actually didn't remesh it. And it chopped into his shoulders here a little bit more than I want. So Control Z to undo, and let's move it up to where it's maybe not chopping into his shoulders, and maybe it's a little flatter. Let's see what that looks like. Better. It didn't fill it again because it's still, I guess it won't fill because it's 3 separate regions. That's okay. I think we can deal with that. Let's say, you know, we could iterate on this all day probably. So let's say that's okay. I don't like that it's open, so you can kind of see how it's just hollow on the inside, and your 3D slicers and all, they don't like just surfaces, they need solids. So there is a edit, make solid. This, we're gonna try it, but this could take a long time to do. Our print just ended though, so let's go handle that before we actually I'm gonna do make solid, and then we'll come back to it because it's probably, well, I don't know, it's going pretty fast, but I don't know. All right, print finished. We don't have an end G code either, so it just stopped again. Oh wow, it's really, oh yeah. All right, so this is, let's go back to our spawn. This is what happened with the default settings. It kind of like tried to simplify and fill in all these little it actually looks kind of cool because it makes it more raggedy, but we'd never be able to print that. So what we need to do instead is, instead of the fast, let's do accurate and see if that's any better. All right, we need to move this out of the way. So main menu, I'm on the screen over here, move in X. So I don't know if you can see or not, but maybe if I zoom in a little bit, since we don't have an NG code that moves the nozzle out of the way, it kind of melted a little bit right there. We have not tuned our printer much at all, but it did print fine. And so there's a lot of squish at the bottom. That first couple of layers is really squished out. From, you can see that. Look out, a lot of elephant foot going on there. That's because of the Z offset from the probe is not right. All right, so let's get this out of the way. Change the filament. Oh, so let's get our temperature home. No, not that kind of home. Main menu home. Temperature for PLA, so that we can change out to our arrow. spawn has not respawned over here. Oh wow. Alright, so that's not good. I'm just going to give it some more accuracy. Let it update again. I might could just, alright, got that out of the way. We might could just select that top part and try to remesh it to make it solid. Alright, so here's our arrow filament. Looks like my camera froze again. There it goes. We're using Bamboo Lab arrow, but we're not going to put it on the Bamboo printer. We'll just print it on this same printer. Okay. Alright, so this is one of the ones that I was talking about for the packaging. So vacuum sealed, but it does have a Ziploc. So this one we can actually just open and then reseal it later. Alright, so I got the light gray. I didn't remember, but there's usually a white and a light gray, so I got the light gray apparently. Okay, let's put our bag down. Let's get the desiccant out of there. Let's change out from our, oh yeah, let me show you the color. So there was the champagne metal, I think from Elegoo. I don't know. It is, I wouldn't call it a silk. Look, we've got to really work on our Z-seam. That's really pretty bad. All of that stuff we have to change now because we restarted the whole printer when we changed out the board. We'll not worry with it right now though. So it's a little bit silky, but not like super shiny, and I don't know, it looks nice for our bad print anyway. Alright, so let's take this filament out. So I usually like to push through a little bit and then pull it out. And let's get our nub out of there. And the PLA arrow, let's see if I can find the end of it. Here it is. Let's see about spawn over here. Whoa, alright. More accuracy is needed. It's getting better, but not what we want. Alright, finally. They had it taped to the edge and it was hard to get out of there. Okay. So there's nothing special about loading the arrow versus any other filament. It loads just the same. I say that and now there it goes. I'm just pushing some through to try and get the previous filament out. Alright. Let's see what we're at over. Alright, so we'll have to look at this. So it did fill in, but it really went crazy on some of these thinner areas like the cloak. Now this is a decent thing to be aware of. What it's telling me is that this cloak is really thin, so it may not print very well on FDM printing anyway. Let's cancel all of that remesh stuff and let's see if I can select and remesh just an area up here. I don't know. Let's see, I've got edit, I've got remesh, but I actually want to make it solid is what I want to do. Modify that's just talking about modifying the selection. I could convert to solid part. Ooh, I don't know. Let's click that and see. Append to mesh, yes. Let's see. Let's see what happens. I don't know. Didn't do what I wanted it to do. So I may have to, or did it fill? No, I didn't fill those in. All right. We'll have to see if we can get those filled in. But let's do that in a second. All right, where are we at? We need to go to Cura. So these are the exact same settings we used last time, except we need, we picked 220, which it said at 220 we need a 76% flow rate. So let's change that. So let's just type flow and find our flow rate, the main one that controls all of them, and go to, this one's in percentage, sometimes they're in decimal, this one's percent, so 76%. And reslice, and preview just to make sure that it looks the same. Now, you can kind of see where it looks, it's trying to show that you're not extruding enough filament here, and there's gaps in everything. Hopefully, the expansion of the filament fills in those gaps. That, because look, there's a really big gap between the walls, and then there were gaps on the top and probably on the bottom too. All right, so let's save that, and let's do Aero PLA on the desktop, and let's go to our. Let's reset our printing temperature to 220, our bed to 50, and again with the Aero, if we printed this hotter and hotter up to, I don't know what it would go to, let's see, 270, then we use lower and lower flow rates. It's going to expand more and more, so we get more weight savings. Right now we're going for like a 30-ish%, 35% weight savings, and we'll see if that's what we get. All right, so let's G-code files. Let's upload the Aero PLA right there, and let's go over here. Let's rehome everything. It probably is okay, but let's rehome everything. Let's save that Z offset since we kind of tuned it a little bit once it homes. Okay. All right, save the Z offset, which will make, so it writes the new Z offset to the printer.cfg file, configuration file. So it restarts the machine, which means I need to restart all these 220, 50, rehome everything. So it's having to home again. Normally you wouldn't have to manually home like this. It's because we don't have a start G-code built. Alright, now should be able to print this. Let's see, we may have to adjust. That looks reasonable. The first little bit, since we don't have a purge line anywhere, the first little bit was a little shaky looking, but it's looking reasonable right now. It's still squished quite a bit, which is our Z offset is still too close, bringing the nozzle too close to the bed, but it's okay. It will stick down at least. And then our goal is, I had a little scale, here it is. Our goal is that we have a much lighter part. The application for this is usually in the RC plane. You know, you need a structural thing that it's not going to be super strong because it is more air than plastic in the regular PLA, but you need lightweight and some structure. So a lot of people use these in model planes and things like that. Maybe I can find a good example of what these might look like. Let's see. There was one that was really popular. Let's see. Here we go. So this is plainprint.com. These are meant for printing with this lightweight PLA. So, you know, all sorts of things. Now these are not free generally. Let's see what the cost of these are. 70 euros. So I don't know what the conversion rate brings that to, but you get just the print files to print with. So you get your own filament. They usually give you print profiles. A lot of times these will even be 3MF files where you just have to load it onto your printer. You don't have to do anything other than buy the filament and load it up. This one does say it needs a 200 by 200 by 200 millimeter printer, and it's saying that it's using the mostly like 1.5 kilograms-ish, a little over, of the lightweight PLA. LW PLA is the bamboo arrow, or lightweight PLA, or foaming PLA. Now I will say that the bamboo, anyway, and generally true, the price, oh, it's down here at the bottom, 1 kilogram of it is $45. So you have to keep into mind that okay, it's not super cheap, and you're going to need 2 of those. So there's $90 right there. You need a third of a roll of regular PLA, probably for landing gear or something like that. And then you need a little bit of TPU so you can make the wheels, or well, not the wheels, the tires. A little bit, not much. So that's the normal application. Oh, here it actually shows down the breakdown of what the different pieces are. So the orange stuff is like carbon fiber rods you might have to get, stuff like that. Actually, in this case, I don't know if that's what these are, but it just says other. Yeah, the TPU is the tires and a little bit of strut there, it looks like, or I'm not sure where that's saying it's going. Obviously, you have to have your radios and your servos and all that too. So this is not the only site. This is just the normal or a typical application for these lightweight PLA stuff. So far ours is printing relatively well. I mean, considering we did no tuning at all. So we'll see if it actually comes out lighter weight than the regular PLA cube. Same size, but lighter weight. Alright, let's see what Meshmixer's doing. We were trying to decide... Oh, let's see. Oh, that whole time I was talking to you, I don't think you saw the this is what I was showing you, that this is plainprint.com, and this is the plane that I just randomly picked out, one from the list here. They have all sorts of birds. Some of these sites have like one that's relatively simplified and free. I don't know if this particular site does, but some of them have a free simple glider or something like that that you can test things out with. I don't know that this site has one though, but some of them, just type in RC 3D printed plane and you'll find several of these types of sites. All right, now let's go back to Spawn. Let's just let's not worry with the hole right now. That will create problems for us, but I don't want to spend the amount of time it takes to get the feel fixed. And actually, you know what? I think we can do it pretty quick. Let me undo enough times to get back to where it was. We may just have to reload it, but let's see. I don't know how many stages of undo I have in here. Because there is one thing, if we can get back to it. Alright, so let's cancel that cut. All right, so what we can do is we can unselect these wings, you know, whatever they are, and just get his head, and I think it'll work better. Let's see if we can get it zoomed in to where we can just select his head. So let's clear the selection, and let's actually make a new selection. Oh, no. Probably should have zoomed in a little more. Or use the straight line tool. Alright, so now it's just his head, a little bit of his shoulders, that's fine. Now when we do our edit plane cut, it should only, and we need to cut the other side, so let's flip it over. Something kind of like that. And let's get it to where it's just his neck. It probably will fill that in better. Okay. Oh, we went a little too far. Control Z. Go up a tiny bit. There. Alright, so now it refilled it. So he's got a little stub for a neck now. Alright, now let's bring in our other guy. So File, Import. This one we're going to append because we want both of these. We don't want to replace the body. So append. And it was the number 1 here. Our little arrow thing is still going strong. These are probably not scaled at all correctly, so we'll see what happens when we bring this in. Hopefully we'll at least get his head. Alright, so let's see, where did it go? There it is down there. Alright, so I think what we need to do is first we need to let's do the analysis on it. And so also I have this object browser now where I can flip between the 2 different objects in there, so make sure we're actually editing the one I want. Let's go ahead and inspect it so that it can repair whatever little holes it has. Now let's edit, transform, so that we can get it kind of the same orientation. So something like that, and it needs to rotate around. And then obviously it needs to go up. We could make a, you know, there are reasons we might want a really large one like that, I suppose. Let's slide it over to the side so that we can isolate just the head and get rid of everything else. So we'll accept that for now, and let's go to our select, and let's just use the brush and try to select the head. I don't know if the brush is a better tool or the I think actually, let's clear select. I think the lasso is a better tool. But let's zoom in on it so that it, can't remember which commands do what. Lasso. And let's use the straight line version of it. Okay, we did go, you know, a little beyond, but that's just the way it is right now. Let us invert the selection, so modify invert. And let's just hit delete to erase that stuff. And then let's try and clean up this collar some. So let's still use the lasso, I guess, and kind of come in here. Just delete that. Got a little more around there. We need some of his neck left. We'll have to deal with that, I guess. Let's try and get that rid of that. Did I not? having issues with selecting. There we go. Okay. Kind of okay. Still have some issues. That one somehow managed to have a solid part there, I guess, in the way it was created. Let's see if we can give it a solid part here with a plane cut. So last time we did the plane cut in the select menu. There's also edit plane cut over here, since we aren't having to isolate anything, so I think we'll be all right. So let's do something. Oh, it's very laggy now. Like this. Let's go from this side because I'm seeing the other one. Alright, so I think maybe that cuts through everything. I want it to do the automatic fill is what I want it to do, which I don't know how it's going to work, but we'll see. It did not. It's a shame. Let's, maybe we'll just slice up. I don't want to slice the bottom of his chin off. Alright, that's better. Alright. Now, let us scale it to a reasonable size. So edit, transform, and this these boxes let us scale. And then let's try and move it into the right spot. Still too big. Let's see, the middle mouse. This is what. Get it lined up more or less. Alright, let's zoom out. I think it's still a little too large. Yeah, a little bit too large. We could be more exact, but let's say that we're good with that. And then let's line it up. Let's see if I'm anywhere near lined up. That actually is relatively lined up. Got a big gap back there. It's okay. Let's say that's good. Accept. Now they're not one model. This is still two separate models. So you can just line things up, have them overlap a little bit. Oh, our print finished. Have them overlap a little bit, and then export all the things at once. And when you bring them into your printer, say that they're into your slicer rather. When you bring them into your slicer, say that they're part of the same model, and it won't reorient them. It'll just keep them in place. And just the fact that they overlap will weld them together, but you might have some weird slicing issues. So it'd be better if we can actually weld these together over here. So one thing we need to do is we need to make these actually overlap. So I've got the head selected, and then I've got this tool here in Meshmixer that lets me just directly sculpt on parts. So I've got all these brushes. I could just move things around, which doesn't add any geometry. It just kind of reforms it. Inflate might be good here, but I'm thinking draw is what I want. So now you can kind of see how big of a cursor I have. I need that to be much smaller. Maybe like that. And it's going to actually draw new geometry on the part I have selected. Now it's not affecting the body. It's only the head because that's what I have selected right now. That one's. Let's get a bigger brush here. Now you have to be careful. You might be doing stuff to the front. I am not. It's going through there. That's fine for now. I just want these to actually overlap. I did kind of change his jawline there. Let's see where I started to change. All right, so there, it's still good. So I do have to be careful. Maybe I should draw from this side. Or maybe we should just move. Move is probably safer. And this one just lets us kind of drag down. That probably changed his... can't tell. Now they overlap. So now, this one might take a while, but we can select both of these. So I just hit Shift and selected both of these, and I've got Boolean union. So that is whatever selected, anywhere they overlap, they will be unioned into one part. So I'm going to try it and see if it will actually give us one part here. Well, while it's doing its thing, let's go to our printer. This, again, no NG code, so we're not moved out of the way here. Oh, so it's actually stuck to the nozzle. There we go. So I left the nozzle sitting on there too long, and it stuck to it. All right, so let's get our little scale over here. Go down here. Which way is right side up? Okay, you're down there. All right. So can you read the scale? I think so. All right. These are grams. So there's the regular PLA, 4.43 grams. Same exact settings except for flow rate. And so, you know, they are the same size. I don't think this could be some leaked filament. I don't know if this is extra filament or if it just melted what was there. 3.44 grams. So it is lighter. What is the ratio? Let's see. We had 3. Another one was 4.44. Oh, did it wrong. Got to do some parentheses. I was doing math in Google browser, and order of operations was off. So it says that that's 23% difference. We were going for 30% difference. There is a decent amount of filament that's piled up there that probably leaked, because since with no NG code, for one, it didn't move out of the way, but also it didn't retract anything. So that extra filament is probably, let me see if I can snip it off of there. Yeah, so I just snipped it off of there, and there is a surface underneath there. So now we're at 3.41. So let's see what that does. 23%. 23.2% weight savings. So not the 30% that we were going for. So we probably need to tune our flow rate a little bit. But it did print. There's no gaps. There is a little bit of an odd top layer here, which actually I think means that it might be over foaming in this area, because when it printed the top, which is a different pattern, it's indented some. It also has a matte feel. Actually, the Z-seam is a lot clearer on it. Let's get you down closer to it. This is a parallax. That the lines on that are a parallax thing from the camera, so they're not in there. There are print lines, but not like that. There is actually one that kind of runs across there. Speaking of that one, I don't know if you can see that line right there. That is probably infill sticking through the, like poking through the walls. So we probably have, oh, you know what? I think we did have a weird infill setting with that other filament, that time-class filament. I think I had to change the infill settings, and that might be why that's showing through. The other thing, obviously it's lighter weight, but it also has a very matte texture, so it's rough, kind of like sandpaper. So that's not bad. or anything, but one thing that's interesting is that I'm zoomed in. I don't know how close we're really close to it right now, and you can barely see the layer lines in it. And remember, these were 0.3 millimeter layer lines, so you do hide a lot of these matte filaments. Not necessarily just the lightweight PLA, but the ones that are matte, they do hide layer lines really well, and they have a interesting texture. So you can feel the texture on this versus what you normally expect on like a regular PLA print. So it's the same size as the other one. Can't get them lined up. Same size and everything, but in our case, it came out 23% lighter, and we were on the really pretty low end for temperature for the Aero. We could print another 30 degrees or more hotter, and it would expand more and more. So obviously, the more you expand, the more air becomes part of your print, and it becomes weaker. I don't have the feeling that this is weak at all. Really, it feels just as strong as any other print. It's just lighter. But if you start expanding more and more, then it probably will get to be a weaker and weaker part. All right, here's what we ended up with. It's all one color now. Well, assuming that we're accepting it, then it's kind of weird back there, but accept. Oh, all right, so this is what I'm, and I haven't been saving, but this is a true thing that happens with Meshmixer, and you're dealing with larger and larger model files, is sometimes it just crashes. And that's what happened to us here. I should have been saving all along. I saved it one time, but after we did this, kind of rearranging, I should have saved it, but I didn't. So it's gonna crash on us. Before it crashes, when I click OK, it probably will crash. Maybe it'll just abort the operation. I don't know, but it'll probably crash the whole thing. I could have cleaned this up a little bit more so that it may have had a better chance. I could have not tried to do such a tight tolerance on the union. I could have been a little looser on that. But once we get it actually welded together into one part, then when we go to sculpt, we can go in and sculpt these two together. And my next goal would have been to smooth out this big lump back here. Then also go through, and we have to decide in our case here, how are we going to print this? Is this a resin print or a FDM print? If it's FDM, then we really need to do something with a lot of this stuff that's not going to print very well because it's thin and it has lots of overhangs. So we need to go in and thicken things up, maybe attach his cloak to his body somehow a little better. If it's resin, then maybe we can get away with some of this. There's still going to be supports everywhere, but it might be able to handle the thinness, the fidelity of the cape better than FDM would. I'm going to click OK, see what happens. Well, it actually didn't crash the whole thing. It only crashed the operation there. So in that case, I could just try to redo it again with some less aggressive settings. I don't think you want to sit here and watch. The idea is that you can take two different models and line them up, scale them, trim them down, sculpt them a little bit, and do a Boolean union. And they have others, difference and intersection for different purposes, but Boolean union to create them into one model, and then refine that and take it to the printer. Export it as a STL or 3MF and take it to the printer. And actually, oh yeah, this was fine last time. It was when I did accept. So you could probably do maybe like fast approximate, maybe. It doesn't let you choose these until after it's already done the first one. I don't know why. And we could have maybe done some, maybe not auto reduce the result, maybe not preserve group boundaries. I'm not sure exactly what triggered the fault. Seems like the fast approximate is slower than the precise was. We're almost out of time though. So what's coming up is there was a request for making parts stronger, particularly with the particularly with the idea. All right, so we have to figure out what's going on with that. And I don't know. We could just leave it the way it is and try to print it. It's probably something with this overlap is not happy. But I did find for the annealing part, I found a cheap toaster. Just like this kind. So, just a cheap, little toaster at the thrift store for $7, $6.75. I don't know. So the annealing of printed parts, and is it annealing or heat treating? It's kind of hard to say. It's not quite the same chemical, crystalline process that annealing a metal would be, because it is plastic. So it's maybe not technically annealing, but it's doing the same kind of things. You're heating something, the plastic up, you're letting it reform crystalline structure in one way or another. In our case, you might lose some polymerization. That's hard for me to say, but you might gain some better layer adhesion type stuff. And we need to heat it up in a relatively controlled but not super hot environment. So you can't just throw it in a oven or something like that. Plus, you probably don't want to put your printed stuff in an oven that you're going to cook food in, just for the sake of you've got all this off-gassing and all kind of stuff that might not be good. Plus, it's possible that you end up forgetting it or going too hot and it melts, and then you've got a giant mess to deal with. We've got this toaster. I don't know how accurate it's going to be temperature-wise. Maybe we need to build a little internal temperature sensor, just a thermistor or something to measure the temperature, because all I've got is a dial that shows what temperature it's at, and you just trust that that's true. But the idea is that we can put our plastic printed parts, particularly PLA, into this heated chamber, let it sit for 30 minutes or an hour, let it cool down naturally, and I have a stronger part than I had before. So a lot of it through, better layer adhesion, but there's other things that are happening too, but a lot of it's probably better layer adhesion. And the downside is that too hot or too fast cooling or heating, and it's going to warp, and so you do have to try and control the warping. Now, even in a good anneal or heat treat, whichever you want to call this, it's going to shrink or expand. Maybe a lot of times they shrink in X and Y and expand in Z, and so you do have to account for changes in dimensions in your part. And normally you're annealing something because you want it to be functional, strong, and so that means it probably interfaces with a bigger system. It's connected to stuff, and that changing in dimensions might be a problem. So we'll look at some of that. I'll probably have to do ahead of time the annealing, because it does take, maybe 30 minutes is the minimum amount of time, and then you have to let it cool down. If you take it out too soon, then it's definitely going to warp. So we'll have to see on that, and then we're going to talk through some other ways outside of annealing that you can just make your part stronger, because maybe you want a functional part. Maybe you don't want spawn here. You want something that's a bracket or something that's functional, and you want to figure out how to do that with 3D printing. So that's coming up. We've got a few things left on our X30 that we haven't done in a while, so I need to print the canopy mainly, and then finish off the front landing gear. Those are probably offline. They're probably not in the stream. So we do have our competition on, I think we set that for the 13th, so that's the last class day. I've been looking at the weather and it looks okay. It's like 25% chance of rain that day, but I think that's okay. We need to be outside, so at least the way I'm thinking of it is you launch outside. Otherwise, if you're any kind of hard floor, you're going to get lots of bouncing and rolling and all that kind of stuff. So I was thinking we would be outside. Hopefully the weather holds out to where we can do that. But that leaves us with Wednesday, Friday, and Monday of topics. One of those is strengthening parts. So there's 2 topics left that if you want something last minute, let me know and we'll try. I think one of those is finishing. So there's only one open topic. So strengthening parts, finishing parts, those are 2 of the last 3. And then there's 1 spot left. So if you have an idea that you want to talk through more or something we haven't talked about at all, then let me know, because I think there's 1 spot left open. All right. We'll be back on Wednesday, and I think that's when we'll probably do the annealing or the strengthening lecture, and we'll do some prints